When x is negative 1, y becomes 4. Very nice. All you got to do is, if you don't know how to deal with negative exponents, check it out. All you got to do is type this in your calculator. Look at 2 to the negative 1 power. Let me do it right here for you. Watch this. Let's see, 8 times 2 to the negative 1 power. 8 times, look, I'm going to just put the parentheses, and then I'm going to put I'm going to put negative 1 power. Remember, you press the A to the bth power, this button for the exponent, and look, I'm going to press enter, Rivetta, and look at it, it's positive 4. Nice. Easy stuff. So there's our first y value. Castellana, go ahead and type this in when x is 0 on your calculator, Rivetta. Go ahead and calculate 1, and I'll do 2 and 3. Actually, the calculator looks like this. Watch. Go to desmos.com. On your graph paper, gentlemen, here we go. Yeah, so we just made the table of values. And now what we're going to do is just graph this puppy. Look at the highest y value is 64. So I'm going to go by 5 is good for me. I'm going to go by 5. Gentlemen, I don't mind you guys sitting together, but you guys got to, well, I'm talking, no talking, appreciate it. So let's go by 5s. The highest is 64 on y. So on your graph paper, so here we go. We go 0. We'll go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Make sure you guys give yourself enough room for your y-axis. We're going from 0 to 60 going by 5s. And on the x-axis, we're only going from negative 1 to 3. 5s. And look at the x-axis. I'm going from negative 1, 0, 1, 2, and then 3. So you're going all the way up to 60 on your y-axis. Stop here, right? Well, it's going to be the highest of 64, so it's going to just be right underneath. We already know 65. Yeah, but you're right, technically. And let's start plotting the points. Go ahead, copy that down. I'll give you a minute to copy that down. Let's rock and roll. When x was negative 1, y was 4. So negative 1, 4 is right here. I'm going to put it in Dodger blue since they're going to win tonight. Oh, no. Shame on me. I should know. I know. It's crazy, huh? 0, 8. That was a low blow. 0, 8. Here we go. 0, 8 is right below 10. No worries. I forgive you. 116. Right now, I'll put it up right now. Let me just finish this. 1, right above 15, here's 16. Nice. Ya, Tapia? Nice. Negative 1 was 4. And 232? Oops, my bad. 232. 30 right above here. 32 is about right there. Rocking and rolling. And last one was 364. Way up the heck up here. 364 is way up there. Look at right below 65. You can see the curve. Remember yesterday's half pipe? It's the same kind of thing. Sure. Would this be an exponential growth or decay? Good try. Decay is when it's going down. Okay, so look at from left to right, we're going up crazy. So this would be an exponential growth. Arrow because it goes on infinitely up there. And remember, it gets closer and closer to the x-axis without ever touching infinitely. It's kind of mysterious. 64. And here's the table. You can copy the table down really quick. Franco, hit it. It's kind of mysterious when you think about it. Imagine, let's see, like from me to Casadena, how many feet do you think this is from me to Casadena? About 15, I'd say yes, that's a good estimate. If I said, look, I'm going to walk halfway, the distance between me and Casadena, I'm going to walk halfway forever. Will I ever reach him? Look at, so between me and him it's 15, so I'll walk 7 feet. That's about halfway. Watch this now. What's halfway now between me and him? It's about right here. Now what's halfway? Imagine me getting halfway closer and closer forever, but not ever touching him. Think about it. So halfway now be right here. Halfway now, but right here. Halfway, 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 but never touching Casadena. That's what's going on with the graph and the x-axis. Check it out. Down here, imagine getting infinitely closer and closer and closer and closer, but never touching something. So however small the distance, find halfway between that. However small distance, halfway. Halfway, halfway. How far can you go halfways? How many halfways can you go? Well, the mind can go infinitely. A smaller and smaller fraction. Think of smaller and smaller fraction. It gets crazy. It's weird. All right, so you have your graph paper in front of you. The game plan for today is we're going to go heads against each other. You have the opportunity to have 5 stamps by the end of the day because we're going to play a quizzes game. It's an online platform. Most of you, like Franco knows about this, so does Rodriguez. I can't remember if we've ever done it yet, Rivera or Casadena. Have you been in my class since we played a quizzes? Basically, it's this. I'm going to give you 10 easy questions on exponents just to review. If you get all 10 right, you get an extra 3 stamps. But you're not timed. You're competing against yourself, not against each other. Typically, quizzes, you compete against each other. Right, if you get them all right, you get 3 stamps. If you get 1 wrong, you get 2 extra stamps. But if you get more than 1 wrong, you just got to fix your mistakes. You just get your normal stamp. If you only miss 1, you get 2. If you miss none, you get 3 stamps on top of your 2 extra, or your 2 normal, rather. But we're going to take a little bit of notes before that, and then we'll do the quizzes. So you'll go to join.quiz.com and hit the game code to join. But we'll do this after we take notes. I'm going to pass out the note guide right now. Okay? For about 10 minutes, then we'll play quizzes. Let me play this day in history, too. No, this is the notes. It's a note guide. We'll take notes on this. Here's this day in history. Put your name on this, by the way. This is your note guide for today. What happened May 15th? Watch what happens. This is a very interesting story. This lady, listen to her story. Her name is Madeleine Albright. Watch. It's pretty crazy. Here's something trippy. We've been dealing with exponential equations. No. He came after. You know who did meet him? Mr. Molina. He used to go to Garfield High School when he was teaching. Yeah, ask him. Yeah, that's crazy. Back over here. So during warm-up, we had an exponential equation. It looked like, let me see if this is working here. Seriously? Where at? That's pretty cool. Yeah, I have. Guy's autograph. Hold up here. Give me 1 second. Now for warm-up, we graphed a exponential. Look at an exponential equation. Why is it called exponential, Rivera? Look at this. because the variable is the exponent. And we graphed it, and it became this skateboard-looking ramp called an exponential function. Now, it just so happens that in real life, a lot of things can be described by exponential functions. It's kind of freaky. Let me show you one example. Don't write anything down, just but have your notes in front of you. This is a shell of a nautilus. Does anybody know what a nautilus is in the ocean? It's like an underwater crab, snail-like creature. Gary, what? Seriously? You guys are tripping me out. Anyway, snail is actually a good example. The shell, check this out. The shell of a nautilus, or like say a snail, exhibits mathematical relationship, which is actually an exponential equation. And it causes a lot of scientists to think, you know what, this couldn't have happened by chance. Think about what I'm saying. You have, look at in the nautilus, real quick, Rodriguez, all these chambers inside the shell of a nautilus, the ratios are in perfect mathematical symmetry. In other words, look at this. Look at the first chamber right here, the second chamber. When I say a chamber, it means like a little room. If you cut that nautilus shell right in half, you'd see these little rooms inside the shell, and they're called chambers. Look at this. The first chamber, the volume is 0.836. The second one is 0.889, and again, it keeps getting bigger and bigger and bigger. This is actually an exponential equation describing this. Believe it or not. And you see it in nature. And it caused a lot of scientists to think, wait a minute, this couldn't have come about by chance. There's too much mathematical beauty and mathematical harmony here. No, I'm just making a point about exponential equations. Watch this, though. If you ever want to know if an equation or a relationship is exponential, all you got to do is take the ratios. Look at the first chamber and the second chamber. If you divided them, look at the second divided by the first. Look at the ratio. It's 1.063. How about the third divided by the second? Look at the third divided by second, same ratio, 1.063. The fourth divided by the fifth, 1.063. And this is in nature. It's crazy. You would expect something that if it was random to not have this mathematical beauty and harmony. It causes a lot of scientists to think, you know what? Maybe we didn't come about by chance. Maybe biological systems are not the function of chance and random processes, but the function of an intelligent mind, or maybe aliens, or maybe God. You take your pick. But the point is, there's too much harmony going on for this to have come about by chance. It's kind of crazy. Now, notice how they all became the same ratio. The fifth divided by the sixth, the same ratio. The seventh divided by eighth, and so on. Now look at your paper in front of you. Look what it says for number 1 on this extra practice sheet. It says, determine whether the table represents an exponential function. Okay, well, I'm going to take the second value divided by the first to see what happens. So on your paper, I'm going to write 4 divided by 8, and let's see what I get. I'm going to divide that with my calculator. I just gave you the extra practice. Did I pass it out or no? Yeah, it's right in front of you. So right now, this paper is right in front of you. Go ahead and write 4 divided by 8. And what does it become? It becomes 0.5. All right, let's try the third divided by the second. So the third is 2. Let me take 2 divided by 4. Does that become 0.5? Let me see. 2 divided by 4, sure enough, look at 0.5. Okay, how about the fourth divided by the third? Let's see, 1 divided by 2, is that 0.5? It sure is. Look at that. So you got the same ratio, just like the nautilus shell. Therefore, look at the question. Determine whether the table represents an exponential function. Is number 1 exponential? Yes, because all these have the same ratio. The second to the first is 0.5. The third to the second is 0.5. The fourth to the third is 0.5. So for number 1, go ahead and put yes. Same ratio. What do you guys think? Think about what I did. Yes, Uriega. Go ahead. Quick. All right. So number 1 is yes. How about number 2? What's the second value? Okay, wait, tell me what the second value is? 7. So 7 divided by the first is 3. Let me get the ratio. So 7 divided by 3. Watch this. So I'm taking the second, dividing by the first. Let me get the ratio. I'll do the work for us. You just copy. So 7 divided by 3. I got 2.3. Well, now let's not get excited yet. Let's get the third divided by the second. 11 divided by 7 now. Let's see if I get 2.3 also. If it's not, then I know it's not exponential. 11 divided by 7, I got 1.6. So is number 2 a exponential? No. This is a big fat no. A no burger. Because you have the different ratio. Look at the second to the first ratio was 2.3. The third to the second was 1.6. It's got to be the same ratio like we did in number 1, or like the Nautilus. You with me? That's all we're looking for, same ratio. All right. The second to the first, third to the second, let's do it. So 9 divided by 12. I'll do the work for us. All you got to do is copy right now. 9 divided by 12, I got 0.75. All right. 9 divided by 12. Now let me do 6 divided by 9. The third divided by the second. Let's see what happens. 6 divided by 9. 6 divided by 9. I got 0.67. This one's a big fat no also. So number 3 is a no. Rivette, are you with me? Yeah. Cool. Here we go. Number 4. So far, so good? What up, Velez? 8 stamps. Who wants Saturday school? Rock and roll, guys. How about the 4th one now? Let's see the ratio. The second to the first, I'll do the work for us. Here we go. 0.5 divided by 0.125. Let me get my calculator. So 0.5 divided by 0.125, I get 4. So I took the second value, the second y value divided by the first y value. Look at it, right there. I did it for us. I punched in my calculator. I got 4. Now I'm going to try the third y value divided by the second. Watch this. 2 divided by 0.5. I get 4. This is a yes. It's exponential. If we were to graph it, it would create that ramp of decay or growth. If we were to graph these, but we're not going to graph them right now. All we want to know is if they're exponential or not. So on assignment 44, which you'll see on Big Ideas tomorrow, you'll get questions like this. They'll ask you, is this an exponential function, yes or no? Now you know how to do it. Go ahead and take